Now children, we are going to discuss about the domain and the range of the function, how to find the domain and the range of the function, right? This is very important, right? So let's start with domain. What are domain? Suppose we assume that fx is a function in which x is mapped as y, then domain is all the values of x for which fx exists. That means all the values of x, that means the input values of x, right? So for all the values of x for which fx exists, fx is defined, that means that values will be called the domain. Suppose take an example and discuss with the function fx equals to x plus 1 upon x minus 1 here, right? So you can see that it's a fractional function, and we know that whenever there is a fraction written, the denominator cannot be 0, so that the function to be defined, if the denominator will become 0, the function will not be defined, right children? So that means the denominator of this function will not be 0. Here we have denominator x minus 1, that means the value of x minus 1 will not be equal to 0. That means x will not be equals to 1. That means the domain of the function will be all real numbers except 1, right? So this can be written as this way also, in interval form also. That means the domain of the function will be 1 to minus infinity union 1 to plus infinity. That means only 1 is not included between plus infinity and minus infinity, right? Understood children? Let's start with the range now. In the range, what is range? The output value for the function f, in which x is mapped as y. If x belongs to domain of the function, then all the images of x is called the range, right? So what we'll get? We'll get the range in the set of codomain. Okay, range is basically a subset of codomain, or it could be equal to the codomain also, right? We'll study further. Here we can see that x is mapped as y in a function. The image of 1 is a, the image of 2 is b, the image of 3 is b, right? So the range of the function will be a comma b, because in the codomain only a and b are the elements whose pre-image exists in the domain, right? You can see that there is no pre-image of c is defined in the domain. So we can say that c will not be the part of the function set range, right? Let's start with the example, discuss one example also, in which I have taken a function fx equals to 1 upon root 3 under root 3 minus x, right? So if we calculate the domain of this function, children, what we can say? This is again a fractional function, and in the fractional function denominator cannot be equal to 0. But here we can see that square root is written in the denominator. That means the inside the square root you cannot have a negative term, because if you cannot take the square root of minus, right? Otherwise it will become an imaginary number, not defined. You will get item under root minus 1. So we can say that this 3 minus x will always be greater than 0. Why greater than 0? Because 3 minus x cannot be less than 0, otherwise it will become imaginary function, and 3 minus x cannot be equal to 0 because it's a fractional function, so denominator cannot be 0. That is why the 3 minus x will always be greater than 0. So when we transfer x that side, you can see that x will be less than 3. So from here we can say that the domain of the function will be 3 to minus infinity, right children? Let's find the range of the same function. So we can say that y equals to 1 upon under root 3 minus x written, right? So from here we can say that y will be greater than 0. First case, y will be greater than 0, because the square root will be always a positive term, okay? Because this cannot be negative, and this is not a square. So y will be greater than 0. When we do the, now let's discuss second case. When we do the squaring, y square 3 minus x, right children? So it will become y square upon 1 upon 3 minus x. It will become 1 upon y square 3 minus x, right? So when we transfer cross multiply, we will get 1 upon y square equals to 3 minus x. transfer x that side, what we'll get? X equals to 3 upon 1 upon y square, right? Now here you can see that this y square, this y will cannot be 0, otherwise this term will be not defined. So we can say that the value of y will not be equal to 0 from the second set, and y will be greater than 0. So from these two conclusions we can say that the y belongs to, this is the second case result, y cannot be 0, that means y will be either 0 to minus infinity or 0 to plus infinity, and y will be greater than 0. So from the intersection of these two results we can say that the range of the function will be 0 to infinity. Right children? Note down please. Children, before moving further, try to understand this result. We have studied that if the product of two bracket is 0, that means if x minus a will be 0 or x minus b could be 0. So the value when x minus a equals 0, the value of x will be a, and the value of x minus b when equal to 0, the value of x will be b. So from here we can say that the value of x will be a comma b. Right children? Now try to understand the further if there is the inequality sign in this x minus a, x minus b less than 0 or greater than 0 use. So remember children, whenever x minus a, x minus b less than 0 is written, when a is less than b, then the value of x will lie in between a and b, right? And when x minus a, x minus b greater than 0 and the value of a is less than b, so the value of x will be less than a or the value of x will be greater than b. Okay, I am giving a brief explanation to understand this thing more clearly, that if the product of these two brackets is less than 0, that means the product is negative, and when the product will be negative, that means either this could be positive, this will be negative, or this is positive, this negative, right? Plus into minus, minus, minus into plus, minus, right? Now try to understand. A is less than B, that means this bracket, if this bracket will become positive, then this bracket will be negative, right? And that means this could only be happen when the value of x lies between a and b. That means the value of x is greater than a and less than b. In that case only the first bracket will be positive and second bracket will be negative, and plus into minus will be minus, right? So we can say that this value will be lying between a and b when x minus a and x minus b, the product less than 0. Now see, x minus a, x minus b greater than 0 and the value of a is less than b. Greater than 0 means, what does it mean? Positive value. That means the product of these brackets is positive. When the product is positive, that means either bracket could be negative or positive. That means both could be negative or both could be positive. So minus into minus plus and plus into plus plus. Right children? Now you can see that the value of a is less than b. That means when the value of x is less than a, the first bracket will be negative, which implies that second bracket will also be negative because a is less than b. And when x is greater than b, the value of first bracket and second bracket both will be positive. So we can say that the product will be positive when the value of x is less than a and the value of x is greater than b. Right children? Let's try to solve few more questions where we are finding the domain and the range of the function. Here I have taken a question, fx equals to 1 upon under root 4 minus x square. Now we have to calculate the domain and the range of the function. Right children? Try to understand. This is again a fractional function. So, and the square root is there in the denominator. Inside the square root, the number cannot be less than 0 and the denominator of the fraction cannot be 0, otherwise it will become not defined. Okay, so from here we can say that there are two cases arises. First case says 4 minus x square cannot be equal to 0, and second case says that 4 minus x square will be greater than 0. So when 4 minus x square cannot be equal to 0, that means x square cannot be equal to 4. Therefore we can say that x cannot be equals to plus minus 2. And when x square minus 4 minus x square will be greater than 0, taking minus sign and cross multiplying, x square minus 4 will be less than 0. When we do the factors, what we'll get? X minus x plus 2, x minus 2 less than 0. And we can say that this is x minus a, x minus b less than 0 form written. And when the value of less than 0 there, negative value there, that means the value of x is lying between a and b. Here the value of a is minus 2, b is 2. So x is lying between minus 2 and 2. So when we take the intersection of both the results, we can see that the domain of the function will be 2 comma minus 2 in open interval, because x cannot be equals to plus minus 2. Right, children? Let's discuss the range of the function. How we calculate this range of this function. Suppose y equals to 1 upon under root 4 minus x square is given. From here it is understood that the square root of a real function cannot be 0, non-negative, right? So from here we can say that y will be always greater than 0, right, children? So the value of y will be always positive. And when we do the square both sides, it will become y square equals to 1 upon 4 minus x square, right? When you cross multiply, 4 minus x square will be 1 upon y square, and then transfer y square that side. So it will become x square equals to 4 minus 1 upon y square. That means this value is equal to x square. And x square is the perfect square. That means this value will be always greater than equal to 0. Right, children? So when we can say that 4y square minus 1 will be greater than equal to 0 when taking LCM, y square LCM. We can say that y square minus 1 by 4 will be greater than 0. Doing the factors, y plus 1 by 2, y minus 1 by 2 greater than equal to 0. So from here we can say that y will be less than equals to minus 1 by 2 and y will be greater than equals to 1 by 2. And from here we have concluded that y will be greater than 0. So negative value cannot be taken. Okay. So the intersection of all the results will be the range of the function, which is 1 by 2 to plus infinity. Okay. Note down please. Okay, children, in this sum, we will be calculating the range of the function when the function is given x square plus 2, x belongs to real number, right? Now we will be calculating the range of the function. Let this function be y, and y equals to x square plus 2, and when the value of x square you will calculate, that will be y minus 2. So the value of x is under root y minus 2. Inside the square root, the term will be can be greater than or equal to 0. That means the value of y minus 2 will be greater than 0. When you transfer 2 that side, you will come y is greater than equals to 2. From here we can say that the range of the function will be greater than equal to 2. That means close interval 2 to infinity plus infinity. Right. So this will be the range of this question. See another sum. Here I have taken the modulus function. The function is 3 minus mod of x minus 2, right? We know that the domain of the modulus function is all real numbers. It is defined for all real values of x. So we can say that the domain of the function will be all real numbers. So this will be the domain of the function. Let's come to the range. How we calculate the range. Let this function be y. So y equals to 3 minus mod of x minus 2. When you transfer mod of x minus 2 that side, so mod of x minus 2 will be 3 minus y. So we can say that this mod of x minus 2 will be always be greater than equal to 0. We know that the modulus function either greater than or equal to 0. So that means the value of 3 minus y will also be greater than equal to 0. When you transfer y that side, you will get y will be less than equal to 3. Right, children? So when y is less than equals to 3, this can also be written as 3 to minus infinity. So from 3 to minus infinity. Right. So the range of the function will be this. Okay, children? Note down please. Let's see few more sums, children. In this sum, again a modulus function is there where fx is equals to mod of x minus x upon 2x. So what is mod of x? Mod of x is minus x when x is less than 0, and mod of x is x when x is greater than equal to 0. There are two cases, right, that we have studied in modulus function. So when if we have to calculate the domain of this function, you can see that this is a fractional function written. Okay, so whenever there is a fraction written, the denominator will not be equal to 0. That means 2x cannot be equal to 0 or x cannot be equal to 0. So from here we can say that the domain of the function will be all real numbers except 0. Right, children? Now we calculate the range of the function. So say fx equals to y. So the value of y will be mod of x minus x upon 2x. From here we have categorized the cases that x cannot be equal to 0. And when x is less than 0, it will be minus x. So when x is less than 0, substitute the value of modulus function, which is minus x. So minus x minus 2x upon 2x, that will be minus 1. Right? And when x is greater than 0, the value of mod of x is x. That means x minus x cancelled, that will be 0. So from here we can say that the value of function is minus 1 and 0. So we can say that the range of the function will be minus 1 comma 0. Right, children? Let's see another sum. In this, the function is given mod of x minus 4 upon x minus 4. Again, this is a modulus function. So we can categorize the function. We can define the function as mod of x minus 4 will be minus of x minus 4 when x is less than 4 and plus x minus 4 when x is greater than equal to 4. Right? Again, it's a fraction written. In a fraction, denominator cannot be equal to 0. So from here we can say that the value of 4 minus x cannot be equal to 0. That means the value of x cannot be equal to 4. So from here we can say that the domain of the function will be all real numbers except 4. Right, children? Now let's calculate the range of the function. Let's say fx equals to y. So y will be mod of x upon mod of x minus 4 upon x minus 4. So when x is greater than 0, the value of y will be x minus 4 upon x minus 4. We can cancel this value, both values, then the value answer will be 1. And when x is less than 4, so the value of modulus function will be minus of x minus 4. Again, you can cancel this numerator denominator and you get the value minus 1. Right? So from here we can say that the value of the function is either 1 or minus 1. So the range of the function will be minus 1 comma 1. Right, children? Note down, please. Okay, let's come to another sum. Children, this sum is based on greatest integer function. Now here we have to calculate the domain of this function. Greatest integer function 2x minus 3 equals to 5. Greatest integer, this is square bracket, means between this square bracket any number written between 5 and 6, the value of the function will be 5. Right? Suppose it is written in square bracket 5.7, then 2 it is 5. It is written 5.29, then 2 it is 5. Right? That means the value of 2x minus 3 will be greater than equal to 5 and less than 6. For all these values, the value of the greatest integer function will be 5. So if we add 3 in all the terms, then what we'll get? 2x is greater than equals to 8 and less than 9. Right? On dividing it by 2, we can see that x will be greater than equal to 4 and less than 9 by 2. That will be the domain of the function in the semi-closed interval 4 and 9 by 2. Okay, square bracket 4 and less close open bracket 9 by 2. This means x is greater than equal to 4 and less than 9 by 2. Right. Let's move to another sum. Here the function is fx equals to 1 upon log 9 minus x square. So from here we have to calculate again the domain of the function. So this is a logarithmic function and we know that the value of log cannot be equal to 1 because this fraction, whenever any term is written fraction, the value of the denominator cannot be equal to 0, and we know that the value of log 1 is 0. That means 9 minus x square cannot be equal to 1. This is case 1. And x square cannot be equal to 8 when transferring 9 that side, 1 that side, x square this side. X square will not be equals to 8. On taking the square root, we can say that x cannot be equals to plus minus 2 root 2. Right, children? Now, the negative term log does not exist. That means the value of 9 minus x square will be greater than 0. Right? So, when we cross multiply, take minus common and cross multiply, what will get? X square minus 9 will be less than 0. Right? On doing the factors, what will get? X plus 3, x minus 3 less than 0. From here we can see that the x belongs to minus 3 comma 3. And this value lies in this interval. So we can say that the domain of the function will be open interval minus 3 comma 3 except minus 2 root 2 and plus 2 root 2. Right, children? That will be our answer. That will be the domain of this function. Right? So I hope you have understood all this topic clearly. Try to solve the sums as much as you can, and if you have any problems, doubts, let me know. Okay?